Hey there. Welcome to our channel. We're so glad you're here. Please like, share, and subscribe to join us for awesome content. Also share this video with your family and friends. Let's get started. You lie still, your breath slow, as if the world itself pauses to listen. Around you, the night is vast, a velvet blanket stitched with stars. You imagine yourself floating, weightless, beyond the pull of Earth, where the silence of space wraps you in its gentle arms. The universe feels alive, yet quiet, its heartbeat a faint hum of light from distant galaxies. In this stillness, a question stirs within you. What is antimatter, this mysterious substance that could carry you to the stars? Your mind drifts to the beginning, to the moment the universe was born. Picture a spark, smaller than a grain of sand, hotter than a million suns. In that first breath of existence, the Big Bang, everything came to be. Matter, electrons, protons, the building blocks of you, of Earth, of every star, was born. But alongside it, like a shadow cast by a flame, came antimatter. For every particle, there is a twin, an opposite, a mirror image that holds the same weight, the same essence, but with a subtle difference, like a note played backward. You imagine these particles and antiparticles as dancers in a cosmic ballet, twirling in pairs across the vast stage of the newborn universe. Electrons meet positrons, protons meet antiprotons, each pair a perfect reflection of the other. When they touch, they vanish in a burst of light, a silent explosion of pure energy. This is annihilation, the heart of antimatter's power. You feel a shiver, not of fear, but of awe, as if the universe is whispering a secret meant only for you. In those early moments, matter and antimatter were equal, balanced like two sides of a scale. Yet somehow the balance tipped. A tiny fraction more matter than antimatter survived, a whisper of difference that shaped everything. Without it, there would be no stars, no planets, no you lying here, breathing softly under the night sky. Scientists call this asymmetry a mystery, a puzzle written in the language of physics. You picture it as a river choosing one path over another, carving the universe into existence. Now, your thoughts drift to a laboratory, far from the cosmic dawn. Scientists, with steady hands and curious hearts, chase antimatter's elusive trail. They use machines like the Large Hadron Collider, a vast ring of magnets buried beneath the Earth, humming with purpose. You imagine it as a giant harp, its strings vibrating to summon particles from the void. In these collisions, tiny sparks of antimatter appear, positrons, antiprotons, fleeting like fireflies in a summer dusk. They capture these sparks in magnetic traps, delicate as a spider's web, holding them just long enough to study their secrets. You wonder, why is antimatter so rare? In the universe's vastness, it hides in traces, born in the hearts of stars, in the clash of cosmic rays, or in the flicker of radioactive decay. It's as if the universe guards it, keeping it scarce, a treasure too potent to scatter freely. A single gram of antimatter, you learn, could release energy equal to a nuclear bomb, enough to light a city or propel a rocket to Mars. You feel the weight of that power, not heavy, but luminous, like a star held in your palm. This energy, this possibility, is why antimatter calls to dreamers. You imagine a rocket, sleek and silent, its engines glowing not with fire but with the quiet brilliance of annihilation. Unlike the roaring flames of today's rockets, an antimatter engine would hum softly, transforming matter and antimatter into pure energy with perfect efficiency. You picture yourself aboard, gliding past the moon, the stars stretching out like a promise. With antimatter, journeys that take years could shrink to months, or even weeks, the cosmos no longer so distant. But your mind lingers on the challenge. Antimatter is not easily tamed. It cannot touch matter without vanishing, like a dream dissolving at dawn. To hold it, scientists weave magnetic fields, invisible hands that cradle these particles in a vacuum. You imagine this as a lullaby sung to a restless child, soothing yet precise. Even then, only tiny amounts can be made, a few particles at a time, at a cost greater than gold. You feel the patience of this work, the slow rhythm of discovery, like waves lapping at a shore. As you drift, you think of the stars again, their light steady and ancient. Antimatter, though rare, is part of their story, part of the universe's song. It's a reminder that everything, even you, is made of the same stuff, particles born in that first cosmic spark. You breathe deeply, feeling connected to the vastness, as if the universe itself is cradling you. The question of antimatter's power lingers, soft and unanswered, pulling you toward a deeper mystery. What is it about these particles, these mirror twins, that makes them dance so fleetingly? You rest in that thought, your mind floating like a leaf on a quiet stream, ready to explore the rhythm of their creation, the cosmic dance that waits beyond the void. You lie still, your breath a soft echo of the night's calm. The stars above seem to pulse, their light a gentle rhythm guiding you deeper into the universe's story. You imagine yourself weightless, floating in the vast emptiness of space, where the silence feels alive, humming with secrets. Your mind drifts back to that first moment, the Big Bang, where everything began. A spark so small, so fierce, it birthed both matter and its mirror, antimatter. You wonder about their dance, the way they move together, twirling through the cosmos like partners in an ancient waltz. Picture it now, a stage of infinite darkness, lit only by the glow of creation. Particles emerge, tiny flecks of existence, electrons, protons, quarks, each paired with an antimatter twin. The electron, with its negative charge, finds its positron, positively charged, yet identical in mass, like a reflection in a still pond. Protons, sturdy and positive, meet antiprotons, their opposites, spinning in perfect harmony. You feel the rhythm of this dance, each pair moving in step, their motions a balance so delicate it seems the universe itself holds its breath. This dance is not just motion, but a story of energy. In the universe's first moments, energy poured forth, condensing into these pairs like raindrops forming from a storm. You imagine energy as a river, flowing from the Big Bang's heat, splitting into matter and antimatter as naturally as a stream divides around a stone. Scientists call this pair production, but you see it as a cosmic duet, each particle and antiparticle born together, destined to meet again. When they do, their touch is a spark, a burst of light, pure energy released in a process called annihilation. You picture it like two dancers colliding, their steps dissolving into a flare of brilliance, leaving nothing behind but a memory of light. You linger on this idea of annihilation, not as destruction, but as transformation. A single electron and positron, so small they defy imagining, release energy brighter than a star when they meet. This is the heart of antimatter's power, the reason it could fuel rockets to distant worlds. You feel a quiet thrill, like standing at the edge of a vast ocean, knowing its waves could carry you far. A gram of antimatter, meeting a gram of matter, could release energy to rival a nuclear blast, enough to light a city or push a starship toward Mars. You rest in that thought, the scale of it both humbling and wondrous. But why, you wonder, is this dance so fleeting? In the universe's infancy, matter and antimatter were equal, their numbers perfectly matched. Yet, something shifted, a subtle tilt in the cosmic balance. For every billion pairs of particles, one extra speck of matter survived, while its antimatter twin vanished. This tiny imbalance, this whisper of difference, shaped everything. Without it, matter and antimatter would have canceled each other out, leaving a universe of light and nothing else. No stars, no planets, no you, breathing softly under the night sky. Scientists call this the matter-antimatter asymmetry, a mystery they chase with equations and experiments. You imagine it as a single note, slightly off-key, that changed the universe's song. Your mind drifts to the places where this dance continues. In the hearts of stars, where heat and pressure mimic the Big Bang's fire, antimatter flickers briefly into being. Cosmic rays, speeding through space, collide with stray atoms, sparking positrons that flare and fade. Even on Earth, in the quiet decay of radioactive elements, tiny bursts of antimatter appear, like fireflies in a forest. You picture these moments as echoes of that first dance, reminders that the universe is still creating, still moving to its ancient rhythm. You think of scientists, their minds as curious as yours, watching this dance through machines that hum like distant stars. At places like CERN, they recreate the conditions of the early universe, smashing particles together to summon antimatter's fleeting forms. They trap positrons and antiprotons in magnetic fields, delicate as a breath, studying their steps to understand why matter won the cosmic waltz. You feel a connection to their work, as if their questions are yours, their wonder a thread tying you to the stars. As you float in this thought, the universe feels close, its vastness no longer daunting but intimate, like a story whispered just for you. The dance of particles, of matter and antimatter, is not just a cosmic event but a part of you, your atoms born from that same spark. You wonder where this dance began, how the universe crafted these twins in its fiery heart. Your mind, soft and drifting, carries this question forward, ready to explore the forge where antimatter is born, the glowing crucible waiting just beyond the stars. Your breath is soft, a quiet rhythm beneath the night's embrace. The stars above seem to shimmer, each a beacon calling you deeper into the universe's story. You imagine yourself standing at the edge of creation, weightless, surrounded by a vast forge where the cosmos hammers energy into existence. The air hums with heat, alive with sparks that flicker like fireflies, each one a particle or its antimatter twin. You feel the pulse of this forge, its power both ancient and eternal, and you wonder how it crafts antimatter, this elusive mirror of matter that could light the path to the stars. Picture the universe as a vast workshop, its tools forged in the Big Bang's fire. In that first moment, energy poured forth, a molten river shaping matter and antimatter in equal measure. You see it now, not as a distant event, but as a living process, unfolding in the universe's farthest reaches. Antimatter, though scarce, is born in nature's crucibles, places of unimaginable heat and force. You drift toward one such place, a star, its heart a furnace where temperatures soar to millions of degrees. Here, particles collide, energy twists and positrons, antimatter's lightest sparks, flicker into being only to vanish in a flash of light. You linger on this star, its glow warm against your imagined skin. Its core is a dance of fusion, where hydrogen atoms merge to form helium, releasing energy that makes it shine. In these violent clashes, antimatter appears briefly, like a guest at a crowded feast, born from the excess energy of colliding nuclei. You imagine positrons darting through the star's plasma, meeting electrons in a burst of annihilation, their energy joining the star's radiant song. This is one of nature's forges, a place where antimatter is crafted, however fleetingly, as part of the cosmic cycle. Your mind drifts beyond the stars, to the wilder edges of the universe. Picture cosmic rays, particles racing through space at near-light speed, born in the explosions of dying stars or the hearts of black holes. These rays slam into stray atoms, splitting energy into matter and antimatter pairs. You see it like a stone striking a pond, ripples spreading outward, each ripple a positron or antiproton cast into the void. These antimatter particles drift, rare and solitary, until they meet their opposites, dissolving into light. You feel their journey, brief yet vast, a reminder of the universe's restless energy. Closer to home, you imagine Earth's own quiet forges. In the decay of radioactive elements, like potassium in a banana or uranium in ancient rocks, antimatter appears in whispers. A beta decay, subtle as a sigh, releases a positron, which dances briefly before finding an electron to embrace. You picture this as a tiny spark, unnoticed yet profound, tying your world to the cosmic forge. Even thunderstorms, with their crackling lightning, can summon antimatter in the clash of charged particles, a fleeting gift from the sky's electric heart. You marvel at how antimatter, so rare, is woven into the universe's fabric. It's not a stranger but a partner, born alongside matter in every forge, from the Big Bang to a lightning bolt. Yet its scarcity is a mystery. Why does matter dominate, while antimatter hides in traces? You imagine the universe as a weaver, choosing one thread over another, leaving antimatter as a delicate accent in its tapestry. Scientists ponder this, their minds tracing the forge's heat to understand the imbalance that shaped existence. Your thoughts shift to human hands, reaching for this cosmic spark. In laboratories, scientists mimic nature's forges, using accelerators to smash particles together. You picture the Large Hadron Collider, its ring of magnets humming like a distant lullaby, summoning antimatter in controlled bursts. These machines are forges of their own, crafting positrons and antiprotons to study their secrets. You feel the patience of this work, the quiet awe of capturing something so fleeting, like catching a star's breath in a bottle. As you stand in this imagined forge, the universe feels alive, its energy flowing through you. Antimatter is no longer distant but intimate, a spark that connects you to the stars, to the earth, to the very beginning. You breathe deeply, your mind soft and open, carried by the rhythm of creation. The forge's glow lingers, its heat a promise of power, of journeys yet to come. You wonder what happens when matter and antimatter meet, how their touch could fuel a rocket to the stars. A question that glows softly, guiding you toward the mirror's edge. You rest gently, your breath a soft wave beneath the quiet night. The stars above seem to lean closer, their light a whisper of secrets waiting to unfold. You imagine yourself standing before a vast, invisible mirror, its surface rippling with the essence of the universe. In this mirror, you see not your face, but the dance of matter and its opposite antimatter. They're meeting a spark that could light the cosmos. You feel the pull of this edge, this delicate boundary where annihilation becomes creation, and you wonder how such power could carry you to the stars. Picture yourself holding two tiny grains, one of matter, one of antimatter, each so small they slip through the cracks of imagination. The matter grain is an electron, familiar, a piece of the world you know, your breath, your skin, the earth beneath you. Its antimatter twin, a positron, is identical in weight, in spin, but opposite in charge, like a shadow cast in reverse. You bring them closer, your hands trembling with the weight of possibility. When they touch, they vanish, not in silence, but in a flare of pure energy, brighter than 1,000 suns, a burst that could rival the heart of a star. This is annihilation, the mirror's edge where matter and antimatter dissolve into light. You linger on this moment, the transformation feeling less like destruction and more like a song. Annihilation is not an end, but a release, a perfect conversion of mass into energy. Following the quiet truth of Einstein's equation, E equals mc squared. You imagine it as a river meeting the sea, its form changing but its essence enduring. A single gram of matter meeting a gram of antimatter could release energy to power a city for hours or hurl a rocket toward Mars in weeks. You feel the scale of this power, not heavy, but luminous, like a candle flame held in your palm, its warmth promising journeys beyond the horizon. This energy, so potent, is why antimatter dreams of starships. You picture a rocket, sleek and silent, its engines glowing with the light of annihilation. Unlike the roaring fires of chemical rockets, an antimatter engine would hum softly, its fuel transforming completely into energy with no waste, no ash. You see yourself aboard, gliding past the moon's pale glow, the stars stretching out like a map of possibilities. With antimatter's power, distances shrink. Mars in weeks, Jupiter in months, the outer planets no longer a lifetime away. You breathe deeply, the thought of such voyages wrapping you in a quiet thrill, like a melody you've always known but only now hear. Yet you pause, your mind tracing the edge of this mirror. Annihilation is a delicate dance, one that requires balance. Matter and antimatter must meet in equal measure, each particle paired perfectly with its twin. You imagine them as dancers, stepping toward each other with precision, their embrace a fleeting burst of light. If even a whisper of imbalance occurs, the energy falters, the dance incomplete. Scientists dream of harnessing this, designing engines where antimatter and matter meet in controlled bursts, their energy channeled to push a starship forward. You feel the elegance of this challenge, like threading a needle in the dark. Your thoughts drift to the laboratories where this dream takes shape. Scientists with patient hands study annihilation in tiny, controlled moments. They trap positrons and antiprotons in magnetic fields, invisible nets woven to keep antimatter from touching the world of matter. You picture these traps as glass orbs, glowing faintly, holding sparks that could outshine the sun. In experiments, they measure the light of annihilation, its spectrum a signature of the universe's deepest truths. You feel a connection to their work, their curiosity a mirror of your own, as if you're standing beside them, watching the edge where opposites meet. But the mirror's edge is not without shadows. Antimatter's power is vast, yet its creation is costly, its handling a puzzle of precision. A single stray particle touching the wrong surface could spark a burst no one intends. You imagine this as a tightrope walker, each step deliberate, the balance fragile but possible. Yet, the promise of annihilation outweighs the risk, its energy a beacon for explorers. You see the stars again, their light steady, calling you to dream of rockets that ride this edge, powered by the universe's own alchemy. As you rest in this thought, the mirror's edge feels close, its glow a part of you. The stars above seem to nod, their light a reminder that you, too, are made of particles, born from the same cosmic dance. You wonder what it would mean to harness this power, to craft a starship's heart from the light of annihilation. Your mind, soft and drifting, carries this question forward, ready to explore the ingenuity that could make such dreams real, the human hands reaching for the star's own fire. You lie gently beneath the night sky, your breath a soft tide, rising and falling in rhythm with the stars. Their light feels close, as if they're whispering secrets meant only for you. You imagine yourself holding a starship in your hands, not a model, but a vision, sleek, radiant, its heart alive with the glow of antimatter. This ship, a dream of human ingenuity, could carry you to worlds unseen, its engines powered by the mirror's edge, where matter and antimatter meet in a burst of pure light. You feel the pulse of this possibility, steady and warm, and you wonder how such a heart is crafted, how humans reach for the untouchable. Picture a laboratory, not cold or sterile, but alive with a quiet hum, like a lullaby sung to the universe. Here, scientists work as alchemists once did, not turning lead to gold, but weaving energy into dreams of flight. Their goal is to harness antimatter, that fleeting spark born in cosmic forges, and make it the heart of a starship. You see them, their hands steady, their minds bright with curiosity, as they design engines that could outshine the sun. Antimatter, they know, is no ordinary fuel. It transforms completely into energy, leaving no trace, like a melody fading into silence. You drift closer, imagining the heart of this engine. It's not a roaring furnace, but a delicate chamber where antimatter and matter meet in perfect balance. You picture it as a crystal sphere, glowing faintly, where positrons and electrons, or antiprotons and protons, dance their final waltz. When they touch, their annihilation releases a flood of energy, not as fire, but as a stream of photons, pure and precise, pushing the starship forward with a force unmatched. You feel the elegance of this design, like a poem written in light, each word chosen with care. But antimatter is untouchable, a challenge as great as its promise. You imagine it as a wild bird, too delicate to hold, too radiant to cage. If it touches matter, the walls of a chamber, the air, even a speck of dust, it vanishes in a burst of light. To cradle it, scientists weave magnetic fields, invisible threads spun with precision. You picture these fields as a cradle, rocking gently, holding antimatter particles in a vacuum where they float, untouched, like stars suspended in the night. These traps, called penning traps, hum with electric and magnetic forces, their rhythm steady, their balance perfect. You linger on the intricacy of this work. Creating antimatter is a labor of patience, done in places like CERN, where particle accelerators whirl like cosmic dancers, smashing atoms to summon positrons and antiprotons. You see the process as a gardener tending rare flowers, coaxing life from the smallest seeds. A single collision might yield a handful of particles, each one captured in a magnetic embrace, stored for moments or hours. Producing even a gram of antimatter would take millennia with today's machines, a task so vast it feels like counting every star. Yet, You feel the hope in this effort, the quiet determination to touch the untouchable. Your mind drifts to the engine itself, a marvel of human dreaming. Scientists envision a chamber where antimatter is released in tiny, controlled bursts, meeting matter in a dance of annihilation. The energy, pure and radiant, could be channeled through magnetic nozzles, pushing the starship with a force that makes chemical rockets seem like candles beside a bonfire. You imagine boarding this ship, the hum of its engines a soft lullaby, carrying you past the moon, toward Mars, or even the icy rings of Saturn. The journey feels real, as if the stars are already within reach. But the challenge lingers, a soft shadow in your thoughts. Antimatter's power is vast, yet its creation is costly, its storage a puzzle of precision. You picture scientists as weavers, threading their way through a tapestry of physics, each stitch a step toward the stars. They study annihilation's light, measure its energy, and dream of engines that could make the cosmos a journey, not a destination. You feel a connection to their work, their patience a mirror of the universe's own slow rhythm, crafting galaxies over eons. As you rest in this vision, the starship's heart beats softly in your mind, its glow a promise of voyages yet to come. The stars above seem to nod, their light a reminder that you, too, are part of this cosmic weave, your atoms born from the same energy. You wonder about the power locked in a single gram of antimatter, how it could rival a sun or shrink the vastness of space. Your thoughts, gentle and drifting, carry this wonder forward, ready to explore the weight of that power, the featherlight spark that could light the way to the stars. You rest beneath the night's embrace, your breath a gentle wave, rising and falling as the stars flicker above. Their light feels like a soft touch, guiding you deeper into the universe's quiet song. You imagine holding a single gram of antimatter in your palm, light as a feather, so small it could slip through your fingers unnoticed. Yet, within this tiny speck lies the power of a sun, a force so vast it could carry a starship across the void. You feel the weight of this paradox, the delicate balance of its promise and its rarity, and you wonder how such a small thing could reshape your journey to the stars. Close your eyes and picture this gram, a mote of antimatter, perhaps positrons or antiprotons, each a mirror to the particles of your world. It weighs no more than a feather, less than a breath, yet its meeting with an equal gram of matter would unleash a torrent of energy. You see it as a spark igniting a cosmic fire, a burst of light equal to 43 kilotons of TNT, enough to rival a nuclear explosion or power a city for days. This is the magic of annihilation, where matter and antimatter dissolve into pure energy, leaving no waste, only a radiant pulse that could push a rocket toward the heavens. You linger on this power, its scale both humbling and exhilarating. A chemical rocket, burning tons of fuel, roars to lift a payload to orbit, its flames a fleeting shout against gravity. But an antimatter rocket, fueled by just grams, would hum softly, its energy a whisper that outshines the loudest blaze. You imagine a journey to Mars, a trip that takes months with today's engines, shrinking to weeks, perhaps 40 days, aboard a ship powered by antimatter's light. You see yourself gliding past the red planet's dusty plains, its canyons glowing in the starlight, the voyage swift and serene, like a dream unfolding. Your mind drifts to the stars beyond, to Jupiter's swirling storms or Saturn's icy rings. With antimatter, these worlds could be reached in months, not years, the vastness of space folding beneath the power of a feather's weight. You picture a starship, its engines glowing with the quiet brilliance of annihilation, carrying you to places where humanity has only gazed through telescopes. The thought wraps you in warmth, as if the stars themselves are beckoning, their light a path you could follow. But this power, so luminous, comes with a shadow. Antimatter is rare, a treasure the universe guards closely. You imagine it as a single drop of rain in a desert, precious and fleeting. Producing even a gram would demand energy and time beyond imagining, billions of dollars, centuries of work with today's machines. At places like CERN, scientists coax antimatter into being, particle by particle, in accelerators that hum like distant songs. Each positron or antiproton is a triumph, captured in magnetic traps delicate as a spider's web. You feel the weight of their effort, the patience it demands, like waiting for a star to rise. You ponder the limits of this fuel. To power a starship, even a small one, would require grams, perhaps kilograms, of antimatter, an amount humanity has never made. The largest quantities produced are mere trillionths of a gram, enough to study, but not to fuel a rocket. You imagine scientists as gardeners, nurturing seeds that take eons to grow, their work a slow dance toward a distant harvest. Yet, the promise remains, a spark that refuses to fade. If antimatter could be made more efficiently, perhaps mined from cosmic sources or crafted in new forges, the stars would draw closer. Your thoughts drift to the energy itself, the light of annihilation. Scientists dream of engines where antimatter's power is harnessed in bursts, directed by magnetic fields to propel a ship. You see this as a river channeled through a narrow gate, its flow steady and controlled. The energy could drive plasma or heat propellant, pushing the starship with a force unmatched. You feel the elegance of this vision, like a poem carved in light, each line precise, each word a step toward the cosmos. As you rest in this thought, the stars above seem to pulse, their light a reminder of the power locked in a single gram. You feel connected to the universe, your own atom's part of its vast story, born from the same energy that fuels antimatter's fire. The dream of a starship lingers, its heart glowing with possibility, but the challenge of taming this fuel calls softly. You wonder how scientists might hold this fleeting spark, how they weave the traps that cradle antimatter's light. A question that drifts with you, gentle and unresolved, toward the quiet work of human hands. You lie softly beneath the starlit sky, your breath a gentle rhythm, blending with the quiet pulse of the night. The stars above seem to lean closer, their light a tender invitation to dream. You imagine yourself stepping into a laboratory, not of steel and glass, but of thought. A place where the air hums with possibility, where scientists weave invisible threads to tame the untamable. Antimatter, that fleeting spark of cosmic fire, rests at the heart of this vision, its power waiting to be cradled. You feel the delicate challenge of holding something so potent, so elusive, and you wonder how human hands could capture a force that vanishes at the slightest touch. Picture antimatter as a wild, radiant creature, a flicker of light too swift to grasp. A single positron or antiproton, if it brushes against matter, the walls of a container, a stray atom, even the air itself, dissolves in a burst of energy, like a star winking out. You imagine it as a breath held too close to a flame, gone in an instant. To hold antimatter, scientists must create a space where it floats, untouched, suspended in a vacuum purer than the void between stars. You feel the weight of this task, not heavy, but intricate, like threading a needle with a single ray of light. In your mind's eye, you see the tool they use, a penning trap, a marvel of precision. Picture it as a cradle woven from magnetic fields, its invisible arms rocking gently, holding antimatter particles in a dance of balance. These traps use electric and magnetic forces, humming softly, to keep positrons or antiprotons suspended, far from any surface. You imagine them as glass orbs, glowing faintly, each one a tiny universe where antimatter floats like a dream. The fields must be perfect, their strength unwavering, or the particles will slip away, meeting matter in a flash of annihilation. You feel the patience of this work, steady as a heartbeat, precise as a whispered lullaby. Your thoughts drift to the places where this happens, laboratories like CERN, where accelerators spin particles in endless circles, summoning antimatter from the energy of collisions. Loving this? Hit that subscribe button to keep up with our videos. Also share this video with your family and friends. You picture the process as a weaver at a loom, drawing threads of light from a cosmic spindle. A single collision might yield a positron or antiproton, captured in an instant, guided into the trap's embrace. But the yield is small, a handful of particles at a time, each one a treasure rarer than any gem. You marvel at the scale of this effort, the years spent gathering specks of antimatter, enough to study but not yet enough to fuel a starship's heart. You linger on the challenge of scale. To power a rocket, grams of antimatter are needed billions of times more than what's been made. Today's traps hold mere trillionths of a gram, enough to glimpse antimatter's secrets but not to harness its power. You imagine scientists as gardeners, tending a single fragile bloom, knowing it could one day seed a forest. They dream of better traps, stronger fields, or new ways to produce antimatter, perhaps from cosmic rays or the hearts of stars. You feel their hope, a quiet current running through their work, like a river carving its path over eons. The traps themselves are a dance of physics. You picture the particles inside, spiraling in tight orbits, guided by magnetic fields that hum with precision. The traps must be cold, chilled to near absolute zero, to slow the particles' restless motion. You see this as a winter's breath, calming a storm into stillness. Even then, antimatter resists, its lifetime fleeting minutes, hours at most, before it slips away or meets matter in a burst of light. You feel the fragility of this balance, like holding a soap bubble, its surface shimmering, ready to pop at the slightest touch. Your mind drifts to the future, to dreams of starships where these traps are more than tools of study. You imagine them as the heart of an engine, releasing antimatter in controlled bursts, each meeting with matter a pulse of energy to propel a ship. The traps would need to be perfect, their fields unwavering, their vacuum absolute. You picture this as a symphony, each note struck with care, the music carrying you toward the stars. The challenge feels vast, yet the stars above seem to nod, their light a reminder that humanity has always reached for the impossible. As you rest in this thought, the laboratory fades, but the hum of the traps lingers, a lullaby tying you to the cosmos. You feel connected to the scientists' work, their patience a mirror of the universe's own slow rhythm, crafting galaxies over billions of years. Antimatter, so untamable, feels closer now, its light a spark within your reach. You wonder what it would be like to board a starship powered by this force, to glide toward the stars on the wings of annihilation. Your mind, soft and drifting, carries this dream forward, ready to explore the journey beyond, the voyages waiting in the light of distant worlds. You lie softly beneath the night's velvet canopy, your breath a gentle wave, syncing with the rhythm of the stars. Their light feels like a call, a whisper urging you to leave the earth behind. You imagine stepping aboard a starship, its hull gleaming, its heart pulsing with the quiet fire of antimatter. The air hums with possibility, a soft vibration that feels like hope. You settle into this vision, the ship ready to carry you beyond the moon, past the planets, toward the vastness of the cosmos. You wonder what it would be like to journey on antimatter's wings, to see the stars not as distant lights but as destinations within reach. Picture the starship, sleek and silent, unlike the roaring rockets of today. Its engines don't burn with flame but glow with the light of annihilation, where matter and antimatter meet in a delicate dance. You see the heart of the engine, a chamber where tiny bursts of positrons and electrons, or antiprotons and protons, dissolve into pure energy. This energy, radiant and precise, flows through magnetic nozzles, pushing the ship forward with a force as gentle as a breeze yet stronger than any fuel humanity has known. You feel the motion, smooth and effortless, as if the universe itself is carrying you. Your journey begins with the moon, its silver face growing larger as you glide past. In a chemical rocket, this trip takes days, but with antimatter's power, it could be hours. You imagine the Earth shrinking behind you, a blue marble cradled in the void, its beauty a quiet farewell. The stars ahead seem to brighten, their light no longer distant but inviting, as if they've been waiting for you. You feel a sense of freedom, like a bird loosed from its cage, the cosmos unfolding before you like a map drawn in starlight. Now your mind drifts to Mars, the red planet with its canyons and ancient rivers. Today's rockets take 6 months or more to reach it, but an antimatter-powered ship could arrive in weeks, perhaps 40 days, maybe less. You picture landing on its dusty plains, the rust-colored horizon stretching wide, the thin air whispering of secrets long buried. The journey feels real, not a dream but a possibility, as if you could step onto Mars and feel its soil beneath your feet. You marvel at how antimatter shrinks the vastness of space, turning months into moments, making the solar system a neighborhood rather than a frontier. Your thoughts stretch further, to Jupiter's swirling storms, its clouds banded in gold and crimson. A chemical rocket might take 6 years to reach it, but with antimatter, the voyage could shrink to months. You imagine orbiting its moons, Europa's icy surface glinting, Callisto's ancient craters telling stories of eons past. The gas giant looms large, its presence a quiet majesty, and you feel small yet connected, as if you're part of its timeless dance. The stars beyond call softly, their light a promise of worlds even farther, perhaps Proxima Centauri, a mere whisper away in cosmic terms. You linger on the mechanics of this journey. The starship's engine, powered by annihilation, is a marvel of balance. Scientists envision releasing antimatter in controlled bursts, each meeting with matter producing a pulse of energy. You picture this as a heartbeat, steady and rhythmic, driving the ship forward. The energy could heat a propellant like hydrogen, turning it into plasma that streams from the nozzles, or it could directly propel the ship with photons, pure light pushing against the void. You feel the elegance of this design, like a poem where every word sings, each burst of energy a verse in the song of exploration. But the dream is not without its challenges. Antimatter, so potent, is scarce, and the traps that hold it are delicate, their magnetic fields a fragile cradle. You imagine the starship carrying tiny amounts, grams at most, enough for a journey but not without risk. If the traps fail, if antimatter touches the ship's walls, the burst could be catastrophic. Yet, you trust the care of those who design it, their minds weaving precision into every detail. You see them as navigators charting a course through a storm, their work a testament to human daring. As you glide through this imagined voyage, the stars seem closer, their light a bridge between you and the cosmos. You feel part of something vast, your own atoms echoing the energy of annihilation, born from the same spark that fuels the stars. The journey beyond feels possible, not a distant hope but a path humanity might walk. You wonder, though, about the shadows that linger, the risks of wielding such power, the balance between ambition and caution. Your mind, soft and drifting, carries this thought forward, ready to explore the delicate edge where dreams meet reality, where the stars wait just beyond the veil. You rest gently beneath the night's quiet embrace, your breath a soft ripple in the stillness. The stars above glow with a steady warmth, their light a beacon guiding your thoughts through the vastness of the cosmos. You imagine yourself aboard that antimatter-powered starship, gliding toward distant worlds, its engines humming with the light of annihilation. But now, a soft shadow falls across your dream, not heavy, but thoughtful, like a cloud drifting before the moon. You feel the weight of antimatter's risks, its power as perilous as it is promising, and you wonder how humanity might navigate this delicate balance to reach the stars. Picture antimatter once more, that feather-light spark holding the energy of a sun. Its beauty lies in its annihilation, the perfect meeting of matter and antimatter that births pure light. Yet, this same power is its danger. You imagine a single positron escaping its magnetic cradle, touching the starship's walls, a speck of steel, a stray atom, and vanishing in a burst of energy. A gram of antimatter, mishandled, could release a force equal to a nuclear blast, enough to shatter dreams of exploration. You see this as a fire held too close, its warmth inviting but its flame unforgiving, and you feel the need for caution, like a sailor respecting the sea's might. Your mind drifts to the starship's heart, its engine a delicate dance of precision. The magnetic traps, those invisible cradles, must hold antimatter perfectly, their fields unwavering, their vacuum absolute. You picture them as glass threads spun by a master weaver, each one fragile yet essential. A flicker in the power, a flaw in the design, and the antimatter could slip free, its annihilation sudden and catastrophic. Scientists, you imagine, work like watchmakers, their hands steady, crafting systems where every piece fits flawlessly. You feel their care, their minds threading a path through the shadows of risk. Another shadow looms, the cost of creation. Antimatter is rare, a cosmic treasure born in stars or summoned in human forges like CERN's accelerators. You see these machines as looms weaving particles from energy, but the process is slow, each positron or antiproton a single stitch in a vast tapestry. Producing a gram of antimatter would demand energy equal to a nation's power grid running for years, costing billions, perhaps trillions of dollars. You imagine this as a mountain climbed step by step, the summit distant but not unreachable. The scarcity whispers restraint, urging humanity to weigh the cost against the dream of starflight. Your thoughts linger on the environment beyond the starship. In space, cosmic rays and stray particles could pierce the traps, disrupting their delicate balance. You picture this as a storm battering a ship, its sails fragile against the wind. Shielding the antimatter would require layers of ingenuity. Magnetic fields, reinforced chambers, redundant systems, all adding weight and complexity to the starship. You feel the puzzle of this challenge, like fitting a mosaic where every piece must align. Yet the star's call keeps the dream alive, their light a steady guide. You reflect on Earth, too, where antimatter's creation carries its own risks. Accelerators, though marvels, demand vast energy, their hum a reminder of resources drawn from a planet already stretched. You imagine the laboratories as glowing hearths, warming the future but requiring care not to burn too brightly. Accidents, though rare, could release bursts of radiation, small but sobering. You see scientists as stewards, balancing ambition with responsibility, their work a quiet vow to protect while they reach for the stars. Yet the shadows do not dim the dream. You picture humanity as a river, flowing around obstacles, finding paths through even the darkest valleys. Antimatter's risks are great, but so is its promise. A fuel that could shrink the cosmos, making Mars a neighbor, Jupiter a friend. You imagine new technologies, perhaps harvesting antimatter from space, where cosmic rays or Jupiter's magnetic fields might yield traces of this elusive spark. Or maybe future forges, more efficient than today's, could craft antimatter with less cost, less risk. You feel the hope in these ideas, like seeds planted in fertile soil, waiting for time to bloom. As you rest in this reflection, the stars above seem to pulse, their light a reminder that risk has always walked beside discovery. Fire, steam, electricity, all carried shadows, yet humanity tamed them, weaving their power into progress. Antimatter feels the same, a challenge but not a barrier, its risks a call to ingenuity rather than retreat. You wonder what lies ahead, how this delicate balance might shape the future, how humanity might step into the cosmos with care and courage. Your mind, soft and drifting, carries this thought forward, ready to rest at the horizon of tomorrow, where the stars wait, patient and eternal. You lie gently beneath the night's soft embrace, your breath a quiet tide, rising and falling in harmony with the stars. Their light feels like a promise, each pinprick a story waiting to be told. You imagine yourself standing at the edge of tomorrow, a horizon where the impossible bends toward possibility. In your mind's eye, antimatter rockets shimmer, their engines glowing with the light of annihilation, ready to carry humanity beyond the Earth, toward the vast canvas of the cosmos. You feel the weight of this dream, not heavy, but warm, like a candle's flame guiding you into the future. Picture the universe as a great tapestry, its threads woven from the energy of the Big Bang, its patterns shaped by stars, planets, and the fleeting dance of antimatter. You see yourself as part of this weave, your atoms born from the same spark that fuels those distant rockets. Antimatter, that mirror-like substance, feels less like a mystery now and more like a partner, its power a bridge to worlds unseen. You imagine stepping aboard a starship, its hull sleek, its heart pulsing with the quiet fire of matter and antimatter meeting in perfect balance. The stars ahead seem to nod, their light a welcome, as if they've been waiting for you all along. Your thoughts drift to the journeys these rockets could make real. Mars, with its red deserts and ancient valleys, could be a neighbor, reachable in weeks rather than months. Jupiter's moons, icy Europa and cratered Callisto, could become places to explore, their secrets unveiled in months, not years. You picture gliding past Saturn's rings, their icy shimmer a quiet symphony, or even venturing toward the Kuiper belt, where comets drift like ghosts. With antimatter's power, The solar system shrinks, its vastness no longer a barrier but an invitation. You feel the thrill of this possibility, soft and steady, like a heartbeat echoing through the void. Beyond the solar system, the stars call louder. Proxima Centauri, the closest star, lies 4.2 light-years away, a journey unthinkable with today's rockets. But with antimatter, you imagine a voyage measured in decades, not centuries. The star's faint red glow growing brighter as you approach. You see humanity's first interstellar ship, its engines humming with the light of annihilation, carrying dreams to a new sun. The thought wraps you in warmth, as if the universe itself is whispering encouragement, urging you to dream bigger, to reach further. Yet, this horizon is not without its shadows. You reflect on the challenges, the delicate balance of antimatter's power. This creation, so costly, demands energy and time beyond today's reach. Its storage, in magnetic traps as fragile as a spider's web, requires precision that tests human ingenuity. The risks of annihilation, a burst of energy if mishandled, linger like a quiet caution. But these shadows do not dim the dream. They sharpen it, like stars shining brighter against the dark. You see scientists as navigators, charting a course through these challenges, their work a steady rhythm building toward tomorrow. Your mind drifts to the possibilities of that tomorrow. Perhaps new technologies will harvest antimatter from space, capturing positrons from cosmic rays or Jupiter's magnetic fields. Maybe future accelerators, more efficient than today's, will craft antimatter with less cost, turning grams into reality. You imagine these advances as seeds, planted now, growing slowly into a forest of innovation. The horizon feels alive, not fixed but moving, each step forward bringing the stars closer. You feel the patience of this journey, like a river carving its path through stone, steady and unhurried. As you rest in this vision, you think of humanity's place in the cosmos. The stars are not just destinations but mirrors, reflecting the curiosity that drives you, the same spark that led to fire, to wheels, to flight. Antimatter, with its power and its risks, is another step, a bold leap toward understanding the universe's song. You feel connected to this story, your own existence a note in its melody, born from the same energy that fuels the stars. The dream of antimatter rockets feels like a promise, not just of travel, but of belonging, of finding humanity's place among the vastness. You breathe deeply, the night air cool and calm, the stars above a gentle reminder of what lies ahead. The horizon of tomorrow stretches before you, shimmering with the glow of antimatter, the light of human hope. You wonder what it will be like to live in that future, to see the stars not as distant dreams but as homes waiting to be known. Your mind, soft and drifting, settles into this thought, carried by the quiet rhythm of the cosmos, ready to dream of the journeys yet to come, the stars that wait, patient and eternal, just beyond the edge of sleep. Thanks for watching. Please subscribe, like, and share. See you next time.